All right. Today we're going to start into chapter 5. This should take us about a week. It should not take us any longer than a week to get through. Okay. Chapter 5 is on Euler's circuit problems. Okay. So this comes and brings about all of our graphing for the next 4 chapters. Okay. But we don't graph on an XY axis. Okay. We just graph. So we're going to focus on what we call management science problems, which is finding efficient ways to organize and carry out a large number of complex tasks that do not often appear possible to make optimal decisions. Okay. So basically in this chapter, we're going to figure out ways to route things. We are going to find ways to route or send the delivery of goods, services to an assortment of destinations. So we're going to do what the UPS driver does. We're going to do what the garbage man does. We're going to do what the mailman does. Okay. So we're going to graph, but you're not plotting 2, 3. Okay. Our graphs will consist of dots and lines, though. Okay, so as always, we have to look at some definitions first. Okay, so we've got some key terms we need to talk about. Okay, so our graph is going to consist of vertices. These are the dots or points that are on your graph. Okay, so if you take a look at this graph, give me a dot. What's on the graph? A. So you have vertex A. What other vertices do I have? B, E, D, C. Okay, there are 5 vertices on this graph. The lines or curves that connect them are called edges. Okay, it's very important that you make sure you list all of the edges. So as I list them, I always like to highlight them or trace them with my pencil. So I make sure that I get every last one of them. So I have an edge that connects A to B. I could also write that B to A. The same thing. I have a line that connects A to D. I have a line that connects A to E. Okay. I have 2 lines that connect E to D. So yes, you need to write that twice. So you're showing that there are 2 lines that connect those 2 points. Then I have this edge that comes out of B and loops back around, back to B. So we call that edge BB. You can't just call it B. B is a vertex. You have to call it BB. Questions so far? Okay, we have a fancy edge, and that fancy edge is called a loop. A loop, by definition, is an edge that connects a point to itself. B to B is your loop. Okay. Please understand too that a loop can look like a square. That's a loop. As long as that line comes out of a dot and goes back to that dot before it touches anything else, it is considered a loop. Okay, they can make it even funky looking like this, and that's still a loop. Okay, so don't just necessarily look for a circle. Okay, so your loop here is B back to B. We have what we call multiple edges. By definition, two specific vertices that are connected by more than one edge. Two points or two vertices that are connected by more than one edge. What two vertices in this picture share my multiple edges? E to D. There's two lines, 1, 2, that connect E to D. Okay, again, you can write that E to D, or you can write it D to E. It doesn't matter. It means the same thing. Okay. Your last main term right now is what we call an isolated vertex. This is a vertex with no edges. So in other words, a little lonely dot all by itself. What's my isolated vertex in this picture? C. C. When they're asking you for a vertex set, you list all vertices. Okay, we list all vertices. And when they ask you for an edge set, you list all edges. Okay. So what we did underneath vertex and edge at the top, that's your vertex set and your edge set. We're going to practice, and then we're going to draw. Oh, yes. This is an artsy chapter. You're not going to fail this chapter. Huh? Sure, sorry. Good now? All right. So take a look at graph 1. The first thing they want us to write is the vertex set. So I've got to list all of my vertices. I'm very particular when I do this. I like it in alphabetical order. Okay. So with the vertices, we started A, B, C, D, and E. Those are all your vertices. Your edge set, again, be very, very careful. I trace my lines as I write them. So I make sure I don't duplicate what I've already written, and I make sure that I get every line that is there. So I have a line that connects A to B. I have a line that connects A to E. I have a line that connects B to E. These don't have to be in a specific order as long as you have them all listed. B connects D. B also connects C. C connects E. E connects D. And D connects back to itself. Does this picture have any loops?
Yeah.
What is it?
D.
D to D. Again, please make sure that you write D to D. D itself is just a vertex. D to D is your loop.
So it doesn't count as a loop if another vertex intercepts it?
No. No, a loop has to start at that point, doesn't touch anything else before it gets back there. Okay. Multiple edge. Do I have any multiple edges in this picture? More than one line that connects 2 points? No. Okay, so you're looking for something like AB when you listed your edge set, or CE when you listed your edge set. None of your edges contain the same 2 letters, so there are no multiple edges. Do I have an isolated vertex in this picture?
No.
No. Okay. One more with me, and then I'm going to let you do 3 and 4 on your own before we go over it. Okay. Graph number 2. Vertex set. Again, I'm very particular. M, N, O, P, Q, and R. I don't know, that's just the way my brain works. I love them in alphabetical order. Okay. I have a line that connects Q to M. I have 2 lines that connect M to N, so I need to write that twice. I have a line that connects Q to P. I have a line that connects P to O. There's a line that connects Q to O. And a line that connects P to M. Is there a loop in this picture?
No.
No. Do we have multiple edges? M to N is my multiple edge. Again, you can get that from the picture, or you can get that from the fact that you wrote it twice on here. And do I have an isolated vertex? R. Take a minute or two and try 3 and 4 on your own. Your answers for graph number 3 are on the board. Please make sure that you have 1, 2, 3, 4, 5, 6, 7, 8, 9. There should be 10 edges listed. Make sure you have all 10. They don't have to be in the same order that mine are in, but you must have all 10. There are 2 multiple edges in this one. A lot of people forget about CF because the one loops clear around to the side and one goes straight down through. Okay, there are still 2 lines connecting those 2 points. Even though A is a square, it is still a loop. It still comes out of A and goes directly back before it touches anything else. U, V, W, X, Y, Z. So we got U to U, U to Z, U to Y, Z to X, Z to Y, Y to X, X to X, 3, 4, 5, 6, 7. Loops are U to U, and X to X. You got none, and you've got V and here are your answers for graph 4. Again, your edge set does not have to be in the same order that mine is, but make sure you have all 7. You lose points for every edge that you are missing. So please make sure that you are diligent about making sure you have all of them written down. If you reordered and did like Z to U instead of U to Z, that is okay. You have 2 loops in this picture, U to U and X to X, no multiple edges, and 2 isolated vertices. Any questions? Anybody still need this up?
Yes.
We're going to draw some pretty pictures, and then I'm going to explain to you your Chapter 4 project. Some ugly pictures? No, they're going to be beautiful. Listen, we're not like drawn faces or anything like that. That's okay. I like to have fun with these. We good? All right. Drawing examples. Draw the graphs described.
Oh, no.
On your test, you are going to get your drawing license.
Oh, Lord.
Oh, Lord. These ones are super easy.
Yeah, right.
Okay. So, when you're given examples that look like this, my suggestion to you is start with the vertices that they give you. So, they say we have vertex A, B, C, D, and E. So, somewhere on your page, put A, put B, put C, put D, and put E. As I draw them, I like to check them off. Again, I'm that person that if I don't mark it out, I miss it. So as I do it, I like to cross it off, check it off, whatever you've got to do. Okay. So it tells you what vertices to draw. Then it says, I want these edges drawn. You just have to follow it. So they want an edge that connects A to B. So you're going to take your pencil and connect A to B. Check. If you want to get fancy, when I go to connect B to C, you can make it a little swirly.
That's doing too much. Way too much.
Okay. Keep your straight lines. I don't care. C then connects to D. And finally, D has to connect to E. Check. That's a 100. That's it. I told you, it's not that bad. I'm sure Ashley's is even beautiful over here.
No, it ain't.
Why? Listen. So here's the example that I had in my notes. And it's absolutely perfect.
Wow.
Look at that pretty old straight line. Okay. It doesn't have to be fancy. You just have to have what they want. That's all I'm looking for. Do you have what they want? Okay. So, number 2, we start with those same 5 vertices. You can put them in different positions now. So we got an A. I'm going to put my B over here. I'm going to put my C up here. I like to go a little crazy with it. Bless you. I like to make it fun. Okay. So it doesn't matter where your points are. You just have to have all 5. A's there, B's there, C's there, D's there, E's there. Check. The first thing my edge set wants us to do is connect A to B. Bam. Then it says, I want you to connect A to D. All right, there it is. Check. Now they want you to connect B to C. Check. C to E. Check. C to D. Check. D to A. And D to E. Again, your graph doesn't have to look anything like mine. That's okay. When I check your tests, I'm going to be checking each component to make sure you have them all. Okay. Here's another one that's the same exact thing as what I just drew and is completely correct. I have all 5 vertices. I have all 7 edges. As long as it's all there, it's good. Okay. Try 3 and 4. Oh, yes. Oh, yes, you've got this. Because then I'm going to pick a volunteer to come up and draw their number 3.
Project credit.
And then somebody's going to come up and draw their number 4.
Yeah, like the truth in face credit.
Huh?
Face credit.
No. Who wants to come draw me a pretty picture for number 3? Come on down.
Oh my God,
Like,
you're ugly.
everybody's supposed to look the same.
No.
No.
As long as you have all the components there, I'm good.
Okay.
I'm going to show you, after she's done here, I'm going to show you exactly how I'm going to grade it on your test. That's what takes me so long to grade these tests, because not everybody looks the same. Got 2 lines.
Hello. I'm missing one. Are you? That's why. There.
Okay. So if this was her test, I literally go, okay, we've got RSTU. Check, 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 check. Okay, that's pretty easy to grade. Then I go, all right, she should have a line that connects R to S, that's there. R to T, that's there. R to U, that's there. T to U, that's there. T to S, that's there. That's a 100. Moving on. The funny thing is, that's exactly what I had drawn.
That's crazy.
That's awesome. Okay. Who wants to come up and give me number 4? Don't make me pick people. All right. Say you got me. All right. All 5 vertices. Check, 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 check. She's got a loop that connects back to A, a line that connects A to B, B to C, B to D, C to D, C to E, D to C, D to B, and E to A. This is what I had on my paper. Completely correct. It just looks different. That's okay, as long as all of the elements are there. Okay. The ones you get to have extra fun with are these ones. Okay? Because they don't tell you anything other than just a little bit of information. It's not specific. 5 vertices and 10 edges. So again, start with your vertices. 1, 2, 3, 4, 5. I need 10 edges. So take your pencil and mark yourself 10 lines that crosses these points. It doesn't matter how you do it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Oh, wow.
So when I check this one, I'm going to go through and say, do you have 5 dots? And then I'm going to count your lines. Do you have 10 lines? Perfect. 100. This is what I did on my paper. There's 2 sets. This one is 5 vertices and 10 edges. These 2 go together as a disconnected graph, but there's still 5 vertices and 10 edges all together. So you could even draw graphs in separate pieces. It's just called a disconnected graph at that point. Okay. Okay, number 6. I only need 4 vertices this time. Now it's getting a little bit trickier. I need 1 multiple edge, which means I need to take 2 dots and connect it with 2 lines or more. Okay, so pick any 2 dots you want and connect it with 2 lines to get yourself your multiple edge. Okay, try to do the specifics first. So we've got 4 vertices, we've got a multiple edge, and now it says it wants a total of 6 edges. Well, you drew multiple edges, so we already have 2. So I just need to add on 4 more. 1, 2, 3, 4. Okay.
You draw a line through the middle of that connected.
Wait, what? Where do you want it now?
At the top in the circle.
So like in here?
Yeah.
Yeah, that's fine. That's absolutely fine. Here's what I did on my paper. So here's my multiple edge. So that's 2, 3, 4, 5, 6. I've got all 6. This is another one. Here's my multiple edge. 1, 2. Here's a third one, 4, 5, and 6. Okay. So any of those graphs would have worked. All right, friends, one more. 5 vertices. 1, 2, 3, 4, 5. One of these vertices needs to remain isolated. So all by its lonesome, no edges. Okay, so you can pick any one of your dots that you want to isolate. Does not matter. 2 loops. Pick any 2 dots you want. Give yourself 2 loops. You could have 2 loops coming out of the same dot. That's okay too. And we want 6 total edges. Each loop is 1 edge. So we already have 2. I need to add 4 more. 3, 4, 5, 6. I still have myself my isolated vertex at the top. I have 2 loops and 6 total edges. Here's some other examples. The top one looks just like what I did there, except my loops are in different positions. That bottom one is also the same thing. It's just in 3 different components. Okay. Again, that is A-okay. Question.
That's it.
Okay, we are going to stop there for today because I want to give you guys time to work on your Chapter 4 project because you're going to want the calculators to do that. This is the only day that I'm setting aside time in class to do this. Okay? We need to decide on a due date. So let me talk you